read the unit actually?
Yes,
Have
sir.
you? Okay, so if I may ask, where are you having challenges? Hello?
Yes, sir.
Hello? Yes. So where are you having challenges in unit 2?
Where I have to draw a graph in absolute values.
Oh, okay. Okay, now we are going to look at it. You see, let me just put this a minute. Let me just load the unit 2. Unit 2. A minute. Okay. Oh gosh. A minute. Um, Please, a minute. I want to load the page. Then we'll start.
Page 35, activity 2.6.
Okay. Page 35. I'm loading it now. I'm coming. I want to put it on the screen so that we will see it. I'm putting it on the screen so that we will see it. Say page 35.
Hmm.
Okay, let's see.
Activity 2.6.
Okay, let's see page. Oh, you are referring to this one.
Yes, number 5.
Number 5. Oh, okay. We have. Okay, now we are going to do that. Let me just write the question here. Then we have y equals to absolute value 1 minus x, 2x minus x. Okay. Go this way. Okay. The question says that we have y, and you see that y is equals to we have absolute value of 1 minus x. Then it says that it happens when x is less than minus 1. Then we have 2x minus 3. It happens when x is greater than or equal to minus 2 and less than, oh sorry, yeah, less than or equal to 2. Then we have x squared minus 2. So, yes,
Say where there is 1 minus x, is not x greater than negative 2?
which one?
The first one.
The first one, absolute value of 1 minus x.
If
Uh-huh.
if x is greater than negative 2, you wrote negative 1.
If x is less,
Is
not
less
greater.
is less
Uh,
than negative 2, you wrote
negative
negative 1.
2. Okay, let me change it. Okay. Then here it says that x is greater than 1, greater than 2. So, what you do is that you draw your x and you draw the two axes, x and y axis, obviously. Then let us say we number it. We can have 1, 2, 3, 4. Here you have minus 1, minus 2, minus 3, and let's say minus 4. Then here you have 1, 2, 3, 4. Then here you have minus 1, minus 2, minus 3, minus 4. So let us look at the first one. It's the absolute value of x minus 1. Can you see that if we have absolute value of x minus 1, can you see that your turning point, you can know that your turning point can be 1 and 0. Can we see that? Can we see that?
Yes, sir.
Can you see that?
Yes, sir.
Okay, good. Then your y-intercept will be 0 and 1. Have you seen that? 0 and 1. Then your x-intercept, because it's 0, you are going to only have one of them. So it's going to be 1 and 0. Can you see that?
Yes, sir.
Uh-huh. So actually the graph will look like this. 1 and 0 is here. You see, then 0 and 1 is here. But now the question says that x must be less than 2. You see, so you see it will start like this. It's like a V shape. Eh? So let me use this one. It will come like this here. You see that? Then it will go like this. But it's less than 2. Once it gets here, you must stop. Have you seen that? Because the question says that it's less than what? It's less than 2. Have you seen that?
Yes.
Then you draw a circle here. Have you seen that? To indicate that less than 2. Is that one clear?
Yes.
Okay. Then the next one we have 2x minus 3. Now 2x minus 3, your x-intercept will be 3 over 2x 0. Can you see that?
Yes.
Then your y-intercept will be 0 and minus 3. So 3 over 2 and 0 will be somewhere here. No, it will be here. Then minus 3 will be here. Can you see that? But here it says that your graph must be between minus 2 and what?
And 2.
And 2 inclusive. So you take your this thing, then you draw your line minus 2 to 2. You see that? Then you draw your circle. But you this time you shade. Have you seen that? Because it says that it's inclusive. Have you seen that? Then here to you shade. That doesn't make sense. Does it make sense? Does it make sense?
Start
Which
again.
one?
Start again, sir.
Yeah, you see that it says that it's from minus 2 to 2. Is that clear?
Yes.
So it's a straight line. So that means that I must end at I must start at minus 2 and end at 2. Have you seen that? But you see that if it says it's strictly less than, it's a whole. But if it's like this or like this, it's a whole. Have you seen that? But if it is like this, it's less than or equal to or greater than or equal to, you shade inside. Can you see that? Okay, sorry, Sabelo, I was, no, Mshengu, it's supposed to be plus 2, ne? Less than plus 2, not minus 2. Or it was minus 2. Okay, let's go. So, is the second one clear? Is the second one clear? Is the second one clear? Is it clear?
Yes.
Now, the next one says that it should be greater than 2. S squared. That if you have x squared minus 2, your turning point is 0 and minus 2. How do you say that? The turning point is 0 and minus 2. Can you see that? Hello? Hello?
Yes, sir.
Yes, so your turning point will be here, you see. So the graph will start from here, pass through the turning point and come here. But here it says that x is greater than 2. Have you seen that? So when
Yes.
you get here, you will get a hole like this, then it will continue like this. You don't draw here. Can we see that?
Yes.
Please, any questions there? Yeah. What again is giving a challenge?
Okay. Say?
Yes, that's all.
Yeah.
So have you read on circles and composite functions? Have you read circles and composite functions?
Not yet.
What about the others? What about the others? Okay. Then what you're going to do is that you go and read all those things after composite functions. Then on Monday at yes, on Monday at 12 o'clock, we are going to have another class. Is that clear?
Yes, sir.
So you go and read on them. On Monday, we are going to have another class so that if you have any challenges, we look at them before you write.
Okay.
Is that fine?
Yes.
Uh-huh. Because you yourself have to look at them first, so that if there are any challenges, we can look at them. Because you are writing on Monday, but on Monday at 12 o'clock, we are going to have a class before you write on Monday. Is that fine?
Yeah, it's fine.
Okay. Please, is there any more questions there? Please, are there any more questions there? Okay. Someone says domain and range. Let's see domain and range. Let's see. Let me go back to this files we shared. Yeah. Sabelo, what about domain and range? Sabelo, you are saying domain and range. What is about domain and range that you don't understand? Yes, Sabelo.
Um,
Mm-hmm.
Domain range. Domain is the possible x values of the graph.
Okay. Domain, you see that always a graph, you have to know that it goes from negative infinity Have you seen it? To positive infinity, both domain and range. But at times there are some restrictions. Is that clear? So if there are no restrictions, both domain and range will go from negative infinity to positive. Look at number one. There are no restrictions. Have you seen that? Nothing can restrict the x. Have you seen that? Nothing can restrict the y. So domain can go from negative infinity to positive infinity, and the range can go from negative infinity to positive infinity. Any questions there?
Uh,
One. Yes. I saw Isabello. Number 10, what question? And what page? What activity? Oh, okay, okay. Okay, I've seen it. Number 10 says this, that y equals to absolute value of x minus 1. Sabelo, is that the question you're talking about? Confirm, is that the question you're talking about? Okay. So if you look at here, the domain, there is no restriction. S can take any value, both left and right. Is that clear? There is no restriction for the domain. So domain is going to go from negative infinity to positive infinity. Then if you look at the range you ask yourself, you group it to -1, 0, and 1. Ask yourself, can y be a negative? Because of this absolute value, there's no way y can be a negative. Have you seen that? Can y be 0? Yes, y can be 0. If here is 1, y can be 0. So y can be 0. So sorry, here should be, sorry, I said we should group it when it comes to the range. You should group it to be a negative, 0, and positive. You ask yourself, can y be negative? No, y can never be negative because of the absolute value. Can if I look at the domain and I put the domain here, can y be 0? Yes, y can be 0 because if I put 1 here, y can be 0. Can y be positive? Yes, any number I put here, y can be positive. Yes, that should tell you that y can be positive or 0, greater than or equal to 0. Then we write it this way: 0 inclusive to infinity. Then we get our answer. What's the answer? Okay. So any questions again? Any questions again? Any questions again? I'm waiting for you. Any questions again? Number 11. Okay. Number 11 says we have y equals to x plus 1 all over x squared minus 1. Now let's get the domain. Now the domain has got a restriction. And what's the restriction here? X squared minus 1 can never be 0. Because once it becomes 0, the function becomes undefined. Have you seen that? That means that x squared. Okay, let me write it straight. X squared can never be 1. X can never be minus 1. Have you seen that? That means that x can be any number in the real number system, but it cannot be minus 1 and 1. So how do we write the domain? We write it this way. It will start from negative infinity to negative 1. Then it will start from negative 1 to 1. Then it will go from 1 to infinity. Then we get a domain. Any questions there? Okay, so the range, as I tell you, for the range, you always put negative, 0, positive. You ask yourself, if I put this range, can y be negative? Yes, y can easily be negative. There are so many numbers I can take here and put here that will make y negative. So y can be negative. Correct. Can y be 0? Let me do it well. Negative, 0, positive. Yes, y can be negative. If I pick any number from the domain and put it, y can be negative. Now, can y be 0? Now, is there any number I can replace here to make y 0? Can somebody give me one? Is there any number in the domain that I can replace that can make y 0? Can somebody give me one? There is no number in the domain like that. Is that clear? So it cannot be 0. Can y be positive? Obviously, y can be positive. So we know that y can never be 0. Ne? So it will go like this. From negative infinity to 0, not inclusive. Then from 0, not inclusive, to positive infinity. Is that clear? Okay. Now, any questions again?
Can I ask, Mr. Why do you say negative infinity inclusive? Like I wanna understand the keyword
It's not
inclusive.
negative infinity is not inclusive. Sorry, not inclusive. I'm very sorry. Not inclusive. Is that fine?
Yes.
Okay. So, any questions again? So, any questions again?
Sir, can you explain a little bit about section 4,
Section 4. Let me see
page
section
4?
4.
It's in page 49.
Let me see. What's in 9? Is that page what?
Is section, it start on section 4, page 49. Can you at least do one question so
There's
that I
no page
can?
49 in Unit 2. Page 49 ends, it's only 30 pages. Can we check it correctly?
Unit 2.
Yeah.
Mine it end up in 51 page.
And let me see. Let me see.
It
Oh,
has.
okay. You said page 49. Okay, I understand what you are saying now. I understand what you are saying. Let me see. Oh, what do you call it? Composite
Combine.
function.
Yeah.
Yeah, it's called composite functions.
Can you at least try one equation?
Um, okay. A minute. Okay. So let's look at where I can find the question. Okay, you say that f of x, you can do this example, adding a function, subtracting a function. I don't think that one is a problem. Is that one a problem? Adding a function, subtracting a function, and the problem. Can you hear me? Is that a problem? Hello?
Hello, sir.
Yes, I said that example there, adding a function, subtracting a function, and dividing a function. Is that a problem?
Yeah, I find it difficult.
Oh, you have f of x, g of x. So if they say f of x plus g of x, this is f of x and this is g of x. You just add the two functions. And 4 minus x plus 3 plus x. I don't think this is difficult. Huh? If they say f minus g, you just apply the two functions. The f is 4 minus x minus 3 plus x. I don't think this is difficult. If they say multiply, is 4 minus x times 3 minus x. Then all will be 1 square root 4 minus x three minus x. So what is so difficult here?
I now understand, sir.
Okay. Then if they say divide, is square root of 4 minus x divided by 3 minus x. So it will be all square root 4 minus x 3 minus x. So let's look at another example. Let us look at the other complex number. For instance, you can be given, let's say this, I will say, and you will be asked to find um, f of g and g of f. I will say that. Now, if they say find f of g, let's look at number one. I will say that. If they say find f of g of x, the same as f into bracket g of x. Can you see that? So you first write f, which is x. Wherever you see uh, uh, you see is f into bracket g of x. So wherever you see x in f, you put 3x 4 minus 1 all exponent 10. Have you seen that? Wherever you see x in f, you put g of x. Can you see that?
Yes, sir.
Then if they say the same number one, if they say find g of f, g of f, g of f of x is the same as g f of x So G is 3. Whenever I see X in G, I'll put X 10. All X 4 minus 1. So it will be 3X 40 minus 1. Any questions there? So you can use the same preamble for the rest. Is that clear?
Yes, sir.
Okay. Please, any questions again? Please, any questions again? Please, any questions again? Please, any questions again? Okay, if there are no questions, please go and read the whole chapter. Make sure that you do all the exercises. Is that clear? So if there are any questions, on Monday, I'll come back online. Then we will address them before you. Is that clear?
Okay, sir.
Okay. So in the absence of no questions, we can close the class now. In the absence of no questions, we can close the class now. Is that fine? Is that fine?
Yes, sir.
Okay, thank you very much. Bye.